You all know what parametric equations are, but I thought that some of you might appreciate a quick reminder. Here's a very simple example. Suppose we take the equations where x is equal to 2t squared and y is equal to 4t. Now this is very simple to draw the graph, but in general, if we have something more difficult, we would need to set up a table of values. So if we take values of t, which could be -2, -3/2, -1, 0, 1, 3/2, and 2, x, 2 times t squared, 2 times -2 squared is 8. 2 times -3/2 squared is 9/4 times 2 is 9/2. We lost it. 2 times 1 squared is 2, 0 squared. These are just going to repeat because there's no minus. And y would be 4 times t. 4 times -2, 4 times -3/2, 4 times -1, 4 times 0, 4 times 1, 4 times 3/2, and 4 times 2 is 8. Then we would just plot those points on a graph and join them up. And there we are, all done. You can see the points 2, 4, 2, 4, and then we've got 9/2, 6, 8, 8, 0, 0, and then the same points down below. This is a parabola. In general, the parametric equations for a parabola we have parametric we use x equals a t squared and y equals 2at. You'll notice that if we look at y squared, this is equal to 4a squared t squared, which is 4a times a t squared, and so the Cartesian equation is y squared equals 4ax. We will come back to the parabola later. Now let's look at a different curve. Let's look at the curve where the parametric equations are x equals 2t and y equals 2 divided by t. I'm not going to do a table of values this time. We could plot all the points and we could then join them up and we would get something which was like that. Now, in this case, if we look at x, y, we get 2t times 2/t, which basically gives us that y equals 4 divided by x. This is a hyperbola. Note that with a hyperbola, we have asymptotes. The x-axis and the y-axis are both asymptotes. So we can record that x, y axes are asymptotes. And in this case, we have that the asymptotes are perpendicular. And when this happens, we say that the curve is not just a hyperbola. Y equals 4 over x is a rectangular hyperbola. Well, let's look at what happens if we make it a little bit more general. If we have something more general, then x equals ct, y equals c over t are the normal parametric equations. And all we have to do here is to multiply x by y to give us ct times c over t. Therefore, y equals c squared over x. That is the standard Cartesian equation of a rectangular hyperbola. You can find all this in your textbook, FP1, on pages 41 to 44.